This is Shanko and welcome to part 6 of the Java interview series. So in this video I'm going to talk about databases. So if you're working as an application developer, it is mandatory needing to work with databases, be it a relational database or a non-relational database. So if you are thinking of appearing for an interview as a software engineer, you would definitely be asked questions on databases. So in this video I'm going to talk about relational databases, about RDBMS, and yeah, let's jump into the questions. So the first question is, what is the difference between statement, prepared statement, and callable statement? Now when we are trying to connect to database from the Java layer or from the application layer, we'd be needing a particular interface or particular method to query the database. So basically we have these three options at our disposal: statement, prepared statement, and callable statement. So let's take a look at how each of these work and the differences between them. So first up we have statement. What is statement? Statement interface is used to execute normal SQL queries. Now what are normal SQL queries? We cannot pass parameters to SQL query at runtime using this interface. This interface is mostly used when we are executing a particular SQL query only once. The performance of this interface is less compared to the other two interfaces. Mostly statement interface is used for operations like create, alter, drop, and so on. For example, statement equals to connection dot create statement dot execute update create table employee ID number not null and name. Okay, so what we can see here is we are trying to create a table called employee in our database, and we are using a statement to create that table, right? So statement is basically used for one-time operations like creating a table, altering a table, or dropping a table and stuff like that, right? And we cannot pass parameters. We cannot pass input parameters to our SQL query using statement. And statement also is slower compared to prepared statement and callable statement, right? Next up we have prepared statement. So what is prepared statement? Prepared statement is used to execute parameterized SQL queries. Prepared statement extends the statement interface. We can pass the parameters to SQL query at one time. Using this interface, it is recommended to use prepared statement if you are executing a particular SQL multiple times. It gives better performance than statement interface because prepared statement are pre-compiled and the query plan is created only once, irrespective of how many times we are executing the query. And for example, we have prepared statement pstmt equals connection.prepared statement. So here we are trying to update the employee table, and we are trying to set some name where the ID is something, right? So here we can see we have two question marks in our SQL statement, right? In our SQL query. So these are basically the placeholders which are going to be replaced or which are going to be parameterized, and we can pass in parameters for these, right? So that is exactly what we are doing in the next two lines: pstmt.setString 1 my name. So for the first placeholder we are setting the value as my name, right? And for the second placeholder we are setting the value as 111, right? So we are through this query, what we're trying to do is we are trying to set the name as my name where the ID is 111, right? And then we are doing an execute update. So prepared statement allows us to send in parameters to our SQL query, and if we're trying to update, or if we're trying to fetch records from the database, we are trying to fetch records based on some based on some conditions, based on some where conditions, we should be using prepared statement, right? And next up we have callable statement. So what is callable statement? Callable statement is used to execute stored procedures. Callable statement extends prepared statement. Using callable statement we can pass three types of parameters to stored procedures. They are in, used to pass the values to stored procedure; out, used to hold the result returned by the stored procedure; and in out acts as both in and out parameters. Before calling the stored procedure, you must register out parameters using register out parameter method of callable statement. The performance of this interface is higher than the other two interfaces because it calls the stored procedures which are already compiled and stored in the database server, right? So callable statements are basically used to call stored procedures that we have stored in the database servers. So if we are trying to use prepare statement, we are creating the SQL query, or we are creating the we are writing the query at the application layer, right? But if we try to call some stored procedure that is already stored in the database server, we'll be using a callable statement, right? And apart from this, there are the few important keywords in SQL, or the keywords, the keywords that you would need to work with tables in databases in RDBMS, right? So let's take a look at some of the important keywords about which you should and must be aware of before you attend an interview as a software engineer. So the first one we have is select. So I have already created some tables and I'm using an Oracle database, which is essentially a relational database, and we're going to work with two tables here, customers and orders. So let's take a look at the contents of these two tables. So do a select star from customers, run this. So we have 6 records in our table, and we can see we have these columns: customer ID, customer name, address, city, and country, right? And next we're gonna see the orders table, right? So select star from orders, and that is going to give us all the records from the order table or orders table. And we have order ID, customer ID, order date, and shipper ID inside the order table, right? So first keyword is select. So we have already seen how select works. It is used to fetch records from database, right? So if we do a select star from customers, it gives us all the records that are inside the customers table. And if we do a select star from orders, that gives us all the records that we have inside the orders table, right? So next we have distinct. What is the use of distinct? Now if we take a look at the customers table, we can see that there are multiple records with the same country, right? So what if we need to find out how many countries are there in our table, or how many different countries, how many distinct countries are there in our table, right? So we can say for that, select distinct country, say as country from customers, right? What is this going to give us? This is going to give us the distinct countries that we have in our database. So that is how we can use distinct to find distinct records from our database when we have multiple rows with the same values, right? So next we have where clause. Now let's take a look at how where works. I'm going to say select star from customers, and this is again going to give me all the records inside the database. Now what if I want to see the record for only one customer or only a few customers? So let's say we want the records for, we want the values for the customer with customer ID 1. So how do we do that? We can have a where clause here, and you can say customer underscore ID equals 1. Right, let's run this. So we have only the record for which the customer ID is 1, right? So next up we have and. So this is one condition that we have given, customer ID is 1. And what if we want another if we want to pass another parameter or another condition for our search? So I'll again fetch all the records, right? So what I'm gonna say is where country equals Germany. Right, so this is gonna give me all the records where the country is Germany, right? Now what if I want only the record where country is Germany and the customer name is Chris Miller? So I'm gonna say and customer name equals Chris Miller, right? CHRISMILLER, right? So we have only one record where the country is Germany and where the customer name is Chris Miller. So that is how we can use and, right? Okay, so next up we have or. So what if we want records where country equals Germany or country equals India? So we want records only for those we want only those records where the country is Germany, either Germany or India. So we can see we have only those records where we have country as Germany or as India, right? So, and next up we have not, and not customer ID equals 2, right? So what we are saying here is the country should be Germany and the customer ID should not be 2, right? So for if we select only where country is Germany, we have 2 records for Germany, right? But we are also saying that the customer ID should not be 2. So we have 2 customers, customer ID for which we have customer IDs 1 and 2, which have country as Germany, right? And we are saying here we don't want the one which is with customer ID 2, so it is only showing one record, right? And what is order by? Okay, so if we do a select star from customers, it's going to show us all the records, right? Now what if we want to sort these records by customer name? So what I'm going to do is order by customer name. So this is going to sort the records by customer name in ascending order. So we have first we have name starting with A, and then we have with C and then T, right? And what if we want to change the sorting order to descending? I just say DESC. So now we have the records sorted in a descending order. So first we have T and then C and then name starting with A, right? Okay, so we have row num next up. So what if say we have right, so we have 6 records inside a database, right? What if we want only the first 3? What if we want only the first 3 records? So what I'm going to do is customers where row num is less than equals 3, right? Let's see how this works. So we have only the first 3 records displayed, right? Alright, so next up we have min, max, count, average and sum. So these are basically aggregate functions, and let's see how they work. So I have got another table called student, so I'm just going to show the contents of that table. Right, so let's start from student. So we have 3 records in our table, and what if we want to know the maximum age in this table? So how do we do that? So we can do something like max of age from student, right? So the maximum age is 25, and if you want to find the minimum age, we'll just put minimum age is 20. If you want to know the average age, just put average, and it's 22.66 something, right? And if you want, we have already seen how count works, right? So inside this table we have records where we have records from same countries appearing multiple times, right? So if you want to find out how many records are there for each country, we can do something like select country, comma, count of country as number underscore of underscore records, and we'd say group by country, right? So if we run this is going to show us how many records we have for each country. So for Germany we have 2 records. For Pakistan we have 1 record. For Mexico we have 1 record, and for India we have 2 records, right? And we can also have something like sum. If you want to find the sum of the ages of all the students, so that is 68, right? And then we have also seen how group by works, right? So if you are using an aggregate function, we can group them by a particular column. So here we are grouping them by country. So for each country we want to know how many records are there, or we want to know the count of records, right, for each country. So we can group them by country if you're using an aggregate function such as count, right? And next up we have the joins, right? So let's again take a look at our customers table. And we're gonna simultaneously run the select start from orders as well. So in our customers table we have the customer ID, the customer name, the address, the city and the country, right? And in our orders table we have order ID, customer ID, order date and shipper ID, right? So these 2 tables have a relation. The customers table and orders table have a relation. What is the relation? The customer ID is the relation. The customer ID is the linking column of these 2 tables, right? So we can inside this customer table we can store records for a particular customer, and inside this order table we can store records which are related to the orders that have been placed by a customer. And how do we identify which customer has which order associated with her or him? That is using the customer ID, right? Now let's do something like select customers dot customer name, comma, orders dot order ID orders dot order date, right? And what else? Shipper ID. So I'm gonna say orders dot shipper ID, right? From customers inner join orders on customers dot customer ID equals orders dot customer ID, right? And let's just put this to the next line for readability. Customers, right? So let's run this query and see how it works. Sorry. This seems to be a typo. CUSTOMERS, customer ID, right? Let's run this. Okay. Orders dot customer ID, right? So we have two records displayed. Now what does this exactly, what did I exactly do here? What I'm doing here is I'm trying to fetch the customer name. So we have the customer name, the order ID, we have the order ID, order date, we have the order date, and the shipper ID. So we have the shipper ID, right? From customers inner join orders. So we're going to join the two tables, customers and orders, on customer ID, customers.customer ID equals orders.customer ID, right? So inside customer table we have the customer IDs and the other columns as well, right? And inside the order table we have the customer ID as well. So in this query, what we are trying to do is we are trying to join the two tables and we are trying to fetch those records where the customer IDs match. So we have customer ID 4 and customer ID 1 in our order table, right? So it'll show us only customer ID 4 and customer ID 1 when we run this query, right? So we have, for customer ID 1 we have Thomas Hickerson, and for customer ID 4 we have Alok De, right? So those are the two records that we see when we run this query, right? So inner join is gonna fetch us only those records that match both the tables, right? Now what if we did a left join, left outer join, right? So it is going to show us all the records from the left table. So our left table is customer table and our right table is order table, right? So it is going to show us all the records from the left table even if there is no match. So that is how left join works. What if we did a right join? So right join would fetch us all the records from the right table and only the matching record from the left table. So that is why we have all the records from the right table, which is our order table, and in order table we have two records and both of them match. So we have only those two records displayed here, right? And what if we did a full outer join? So a full outer join is going to give us all the records from both the tables, from our left table as well as from our right table, right? So that is basically how joins work, and you need to have basic knowledge about how joins work in SQL, if you're dealing with relational databases and if you're thinking of appearing for an interview as a software engineer, where the requirement is of an application developer who has to work with relational databases as a backend, right? And next up we have having a keyword, right? So let's take a look at the customers table once again, right? So we have records, 2 records from Germany, 2 records from India, and then 1 record from Pakistan and 1 record from Mexico, right? What if we want to find out those countries for which there are 2 or more records? So we can do that this way. Let's say select country, comma, count of country as a number of records from customer group by country having count of country greater than equals to 2, right? So it'll show us only those countries where the number of records are greater than or equal to 2. So we have Germany, which has 2 records, and India, which has 2 records. So when we are dealing with aggregate functions, we cannot use a where clause. We cannot have a where clause here. That will give us a syntax error. We have to use having, right, instead of a where if you're dealing with aggregate functions, and this will return us those records where the number of records are greater than 2, right? So that is basically it for this video. And yes, there are other stuff that you need to know as well if you're if you want to attend an interview for the position of a software engineer. And you might have to work with other kind of databases as well. So this was the relational part of the backend databases. There might be a requirement where you have to work with non-relational databases as well. So it would be good to have a knowledge or basic idea of how non-relational databases work as well. So yeah, that is basically it for this video. And if you did like this video, then please give it a thumbs up. And if you're not already subscribed, please do consider subscribing for more such content. And thanks for watching.